Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to solve 10 hardest GMAT problem solving questions. So let's go ahead and get started with these questions. So let's get the first one here. So the first question here says that if x is positive, which of the following could be the correct ordering of this number here? So how do we solve this problem? So we've got 1 over x, we've got 2x, and we got x squared. So if we want to find the correct ordering of this, which of the following could be the correct orderings, what we need to do is we need to find the critical points. The points at which these are equal to each other, so that we can find when they are less than each other and when they are greater than each other. So let's find the critical points. So the first critical point is going to be when 1 by x is actually equal to 2x. So that critical point is going to be equal to when 1 is equal to, now since x is positive, I can easily take this to that side. So that's going to be 2x squared, and that would mean x squared is actually equal to 1 by 2, and that would mean x is equal to 1 over square root of 2, which is approximately equal to 1 over 1.4, which is approximately 0.7. So that's one critical point. Let's find the other critical points. I mean, you can do that in just a few seconds. I'm just taking some time. Let's find the other critical point. So the other critical point would be when 1 by x is actually equal to x squared. So you can clearly make the case from here that x cubed has to be equal to 1, which means x has to be 1. So that's another critical point. Another critical point would be when 2x is actually equal to x squared. So this becomes a little quadratic equation. So where x squared minus 2x is actually equal to 0. And if you take the x out, you got x into x minus 2 is 0, which means either x is 0 or x is equal to 2, which would actually make x to be equal to 2 because x is positive. So we got three critical points. We got this one, and this one here. So what I'm going to do is I'm actually going to draw a number line here, and I'm going to map out the critical points. So you got 2 as one critical point. You've got 1 as the other critical point, and you've got 0.7 as the other critical point. So at 0.7, 1 by x is actually equal to 2x, right? So that's there. And if we go towards the right hand side, we would actually get 1 by x to be actually less than 2x, right? I mean, something you can easily figure out, as the 2x is just going to get bigger and bigger. On the other side, you will have 1 by x to be actually greater than 2x. Okay, so this is what happens. Let's see the other critical point. So the other critical point is where x is equal to 2. So at x is equal to 2, you've got 2x. So here you've got 2x is equal to x squared. So if you actually go to the right hand side, you would have x squared to be greater than 2x. And of course, 1 by x is going to be the smallest there. So which is going to be the smallest. And if you go to the left hand side, you're going to have, so left hand side, you're going to have x squared to be actually less than 2x. So 2x is going to be greater than x squared, right? So that's what's going to be there. And on this side, we know that, so on this side, we can easily figure out what's going to be happening to 1 by x. But let's just, we have this particular scenario over here. So let's just talk about this critical point where x is equal to 1. When x is equal to 1, which is this is the case here, you got 1 by x to be equal to x squared. On the right hand side, you can easily say that x squared is going to be greater than 1 by x, right? So from this point to this point, we can say from this point to this point, we can say 2x squared is greater than x squared, which is greater than 1 by x, right? So that's the case. In this case, on the left hand side, which is this particular instance here, you will have 1 by x to be greater than x squared. So that means 2x is going to be greater than 2x is going to be greater than 1 by x, which is going to be greater than x squared. So now we've got all this figured out, right? And then let's see what all answer options we get. So the first answer option is that we have x squared less than 1 by x, which is less than 2x, which is this scenario 2 here, right? So that just sorts itself out. And the other scenario here is we've got 1 by x to be greater than 2x, right? So we've got that. So 1 by x is actually greater than 2x. And of course, we know from here that x squared is the smallest, so x squared comes here. So that would make the first one to be true. Now the third one is not true anywhere. If we have, from here you can see that x squared is the greatest, so it doesn't really work out. In this particular scenario, we know that x squared is in the middle, but 1 by x is the smallest, so the third one is not true here. Similarly, in this scenario as well, 1 by x is the greatest, but x squared is the smallest, so that is not true here. So this one is never true. So from all these answer options, only 1 and 2 are true. So D is the answer. Now, why am I using algebra here? Why am I not using numbers? That's a good question. You can use numbers to solve this problem, but it will confuse you. It will take a lot of time. I know it will take you about a minute and a half to actually set up this number line. However, you will be able to solve this question under 2 minutes if you start with algebra on this question. You can also start choosing numbers. I mean, that's something that you can do. So for instance, I'm just going to clear the screen. So for instance, you can also start dealing with numbers again, but when you start dealing with numbers, you'll have to find the critical points, because this question is not, it doesn't use common scenarios. It's using a scenario by itself. So once you find out that x at 0.7 is a critical point, x at 1 is a critical point, and x at 2 is a critical point, then once you draw this number line out, you would find 1 here, you would find 2 here, and you would find 0.7 here. So what you can do is you can actually pick up a number from here, pick up a number from here, pick up a number from here, and pick up a number from here, and then you can see which scenarios are coming out, right? That would also give you 1 and 2 only, and the third one will not come out anywhere, and you will still get the same answer. So that's another way of solving this problem. However, the key to solving this question is identifying critical points. So the correct answer is D, 1 and 2. So that was a difficult question. I'll give that to the question. So let's move on to the next one. So you can pause this video and you can try this question out by yourself. So this is a probability related question. So this question says that in a room filled with 7 people, 4 people have exactly 1 sibling in the room. So you've got 7 people. So 1, 2, 3, 4. And then you got 3 people who have exactly 2 siblings. So you've got a room with 4 people who have exactly 1 sibling and 3 people who've got exactly 2 siblings. Now, how will this work out? Well, if you've got a person here, that person cannot have more than 1 sibling, which means that person cannot have sibling on this right hand side. So all these 4 people have siblings on this side, and all these 3 people are basically siblings of each other. So they all have 2 siblings in this particular group. So if this person has two siblings, that means he or she got these two siblings, and this person has got these two siblings. So they are siblings of each other, and here they have got exactly one sibling. So basically you have two different groups of people. So now the question is asking, if two people are selected randomly, what is the probability that they are not siblings? So that's what you have to figure out. Now, since you have two groups, what we'll do is we will actually draw two slots. However, we will have two different ways we can actually fill up the slots. What if the first person is selected from this part here, or if the first person is selected from this part here? So what is the probability of selecting 4 people out of 7? So that is 4 out of 7. And once you've selected a person, you're not supposed to select their siblings. So let's suppose you've selected this person and this person is the sibling. Then you're left with 1, 2, 3, 4, 5 people here out of 6 people that you can choose from. Similarly, if you select someone from the right hand side, you can select any 3 people out of 7 people, but now you can't choose their siblings. So basically, if you select this person, then these 2 people are gone and you're left with only 4 people. So if we solve this, this is actually going to be 20 plus 12, which is going to be 32 all the way divided by 42. So that's going to be 16 by 21, which is the answer, option E here. So that wasn't difficult. I mean, that was not a difficult question. So, however, it required a little bit of logic. I mean, when I say that wasn't difficult, I mean, it didn't take us a long time to answer this question. However, if you actually go to online forums, you would see this has been classified as a difficult question. Okay, so I hope this helps. Now let's move on to the next question, which is this. So this question says that if x is greater than y square is greater than z to the power 4, which of the following statements could be true? Now here we don't need to find critical points because this is a common scenario question. So let's just choose some numbers. So you got x here, you got y here, you got z here, right? So what I'm going to do is first of all, I'm going to play with positive numbers. I'm going to make z1, I'm going to make y2, and I'm going to make this 5. Now why did I do that? Because 2 squared is 4, so I want to make sure that I satisfy this condition here. So this condition is definitely satisfied, that is x is greater than y square, which is greater than z to the power 4. So out of these 3 conditions, which condition is satisfied? So you got x greater than y greater than c, so condition 1 is true. Now let's try to make condition 3 true, because you just have to flip the signs for y and z. You just have to make z greater. So I'm just going to keep the same numbers, but I'm just going to flip the sign for y, because once it becomes square, it's still going to satisfy that condition, because minus 2 square is still 4. So this condition is still satisfied. And now that actually gives me 3 is true. Now what I'm going to do is I'm going to try to make number 2 true, and I think this is going to turn out to be true when there are fractions. So I'm just going to make fractions, and this is in the opposite order of each other. You can see these are opposite orders of each other. So I can just make z to be the greatest fraction, then y to be the next greater fraction, and x to be the smallest fraction. So this is 1 by 2, this is 1 by 3, this is 1 by 4. So is the condition satisfied? Is x, which is 1 by 4, greater than y square, which is 1 by 9, greater than z to the power 4, which is 1 by 16? Yes, that is true. And that also makes condition 2 to be true, which means all 3 conditions are satisfied, and the answer is option E. So in this question, there was no need to find critical points. So this was a common question. So you can, and again, you can't just plug in numbers out of the blue. You have to really think, what numbers are you trying for? So I just went for the most obvious option first, and then I kind of switched on those options to see whether if I can make other conditions true. So answer option E is possible. So that's for this question. Now let's move on to the next one. So let's go ahead and solve this question here. So this question says, in the infinite sequence, A an is given to be this expression here where x is a positive integer. What is the value of n? For what value of n is the ratio of this an and this is equal to this? So let's just set it up, right? So they want basically a to the power a of n all the way divided by this expression here to be equal to x to the power 5. So, you know, I think we can first set up the algebraic part and then we can think about plugging in numbers. So you got x to the power n minus 1 plus x to the power n plus x to the power n plus 1 plus x to the power n plus 2 plus n plus 3, right? So that's what it is. Now I think there is room for some algebraic manipulation here. So what I can do is I can take out x to the power n minus 1 so that I can make it look like this one here. So if I take x to the power n minus 1 out, what do I get? Okay. So first of all, for this one, I'm just going to get 1 here. So for this one, I'm taking n minus 1 out of n. So what am I left with? I'm actually just left with an x, right? For this one here, I'm taking n minus 1 out, so I'm left with x squared. For this one, I'm left with x cubed. For this one, I'm left with x to the power 4, right? Let's manipulate further because we can just look at the other side. So x to the power n minus 1 is actually, so if we take this out, so it's going to be 1 plus x is, let's take the x out. So then we're left with 1 plus, so we're still going to be left with, so what are we going to be left with? We're going to be left with x squared, x cubed. Let's just skip a step and write x here and then take x out. So what are we going to be left? What are we going to be left with? We're going to be left with 1 x and x squared, right? So that's what we're going to be left with. So we're going to be left with 1 x. So if I take the x out, so we're going to be left with x and x squared. Let's take one step further, right? So I'm just going to write the step as x to the power n minus 1 all the way to 1 plus x, then 1 plus x. Then I can clearly see that this expression is going to be similar to this, right? I'm going to have 1 plus x, and if I take the x out, I'll have 1 plus x. So that's exactly what I have here, right? Exactly, if I divide this by this expression here, this expression, right? You can clearly see that all this is going to get cancelled out. I'm just going to be left with an x here, right? So this is going to get cancelled out because that's exactly equal to this. So what is this part here? This part here is x to the power n minus 1 minus 1 because I'm just going to take this 1 to the top. So this is x to the power n minus 2, which is actually equal to x to the power 5. So that gives me x to be equal to 7. That solves it, right? So no need to plug in numbers here. So I hope, you know, this doesn't need much of an explanation. All you have to do is you just have to keep following the steps and it got figured out by itself, right? Okay, so I hope this was helpful. Let's move on to the next one. So the answer is B. Okay, so let's solve this question here. So this question says that in a village, there are 100 households. 75 have at least one DVD player, 80 have at least one cell phone, and 55 have at least one MP3 player. So the question is asking us, what is the difference between the greatest and the lowest number of households that can get all three devices? So let's start off with the largest numbers here. So we've got 75 who have DVDs, and you've got 80 people who have cell phone, and we have a maximum of 100 people. So how can I maximize this particular area? Well, if I add 80 and 75, that actually becomes 155. So I have to put 55 people in here so that this total becomes 100. So if I put 55 people here, that means I have to put 20 people here. I have to put 25 people here so that the total becomes 100. And how many people have MP3 players? 55 people. And if I can put all of these people as having MP3 players, which means the value of X, which is the greatest number of people or households who have all three devices, is actually 55. So there's that. So that is the greatest number of households who can have all three devices. Let's try to minimize this. So if I want to minimize this, I would want to be bringing this here and here. I would be spilling it over to the either side. So how many people who have MP3 players can I spill over to the either side? So the maximum number that I can spill over is actually 20 plus 25, that is 45. That means the maximum number of that people that I can spill over is actually 45. I cannot spill over more than that, because then if I do that, then I would be violating this condition that there are 100 people. So that means the minimum that this area can be is actually 10, which is 55 minus 45. So I can only bring out 45 people out of 55 people. So the minimum this has to be is 10, which means the value of y is 10. And the question is asking us the value of x minus y, which is actually equal to 55 minus 45 minus 10, which is 45. So the answer is option C. So hope you understood this problem here. This question, the key to this question is forget the people who have MP3 players. Focus only on the people who have DVDs and cell phone. Identify the constraints there and try to fit in the constraints for the MP3 player at the end. So that was this question, guys. I hope you understood. Let's move on to the next one. So the answer is 45. Okay, so let's see this question. So this question says that in a certain bathtub, there is a cold water tap and a hot water tap, or there's a leak. The cold water leak can fill a bucket in CRs. So the cold one can actually fill the bucket in CRs, and the hot one can fill the bucket in HRs. And we know that C is less than H. So the hot water leak takes a longer time than the cold water leak. If both fixtures began at the same time, they would actually take T. Now, if you've seen the time and rate videos, you would know that from here you can easily say that T is equal to CH over C plus H. So if something takes CRs, the other thing takes HRs, together they take these many Rs. Now the question says that which of the following must be true? Let's see the first one here. So the first one says the number of time it takes to fill the hot water is greater than the total number of hours. Well, this must be true, because the number of the amount of time it takes for just the hot water leak has to be greater than the total amount of time it takes for both the leaks, because both the leaks have to be faster than just the hot water leak. So that must be true, right? Now let's look at this one. Now this one here says the time it takes for cold water leak is less than the time it takes for the tap total, both of them leaking. Well, this cannot be true, because this is something which has to be true, because the cold water leak has to be longer than the total leak. Because if both taps are leaking, it has to take shorter amount of time than just the cold water leaking. So this cannot be true. Let's talk about the third one. The third one here, which uses all of these three expressions here, and then it divides it by 2. So to solve the third one, what we can do is we can actually use this expression here. So let's just bring it out the third one into two parts. So the first one says, is c by 2 less than t? Let's just see if that is possible or not. So we can actually substitute for t here. We can say, is c by 2 less than ch over c plus h, right? So we can just solve this. So is c by 2 less than t, which is ch plus c plus h. So that would actually be is c square plus ch less than 2ch. We can just solve it again. Is c square less than ch, and since c is positive and greater than 0, is c less than h? Well, that is true. It's given here in the question, so that is possible. Let's look at the next one, which is t is less than h by 2. What we'll do is we'll just substitute it back again. This expression is ch over c plus h less than h by 2. So we'll get the same thing, 2ch on this side and ch plus h square on this side, right? Because I'm just taking them to each other side. The only way I can do that if both are positive and greater than 0. So then this one becomes is ch less than h square. Then again is c less than h. Well, that's true again. So that means this one, third one here, must be true, right? So I'm getting the same expression. So the answer option E is the answer, where 1 and 3 are true here. Okay, so I hope you understood this problem here. We didn't have to deal with numbers in here. We can just solve it using algebra. I believe that is a quicker way here. Okay, moving on to the next one. So the answer is option E. So this question says, if x is 3 by 4, y is 2 by 5, what is the value of this expression? Now, I'm assuming there's a trick here. So how can you, what does it look like? Doesn't it look like to be equal to this kind of looks like x squared plus 6x plus 9. I can just, do some quadratic solving here and I can solve this. Or isn't this x plus 3 whole square? I believe that's what it is, right? X plus 3 whole square is actually going to be x squared plus 3 squared plus 2 3x. So that's 6x. So that's what it is. What about this one here, which is y squared plus 1 minus 2y? Isn't that y minus 1 whole square? So that's y minus 1 whole square, right? So how can I deal with square and under root? Well, that's just absolute value. Absolute value of anything is basically equal to the square of that number taken the root of it, right? So that's what absolute values are. So I can just call this as absolute value of x plus 3. And I can just call this as the absolute value of y minus 1. And that's what the question is asking me. So x is 3 by 4. So the absolute value of 3 by 4 plus 3, which is going to be absolute value of 3 plus 12, 15 by 4, right? And this one here is the absolute value of 2 by 5 minus 1, which is actually equal to 3 by 5. So now I just have to subtract these two numbers. So I have to subtract 15 by 4 by 3 by 5. So I can just multiply 4 on both sides here. I can multiply 5 on both sides here. So that's going to be 75 minus 12 divided by 20. So 75 minus 12 is going to be 63 by 20. So that gives me the answer. So the trick to the question was figuring this out, right? And then just canceling this and getting an absolute value actually, right? It's the absolute value. It is not the number itself, right? If you square a number and unsquare root it, you actually get the absolute value. So the answer is option B. So I hope this was helpful. Now let's move on to the next one. Okay, so let's look at this question. So this question says you got these two variables, values, and it says how many ordered pairs are the solutions of the system where x and y are both integers. Now I'm thinking you can plug in some numbers here, but that would be cumbersome because you have to figure out so many different ordered pairs. Let's just do one thing. Let's just kind of draw it out, right? So let's just draw it out. So if we just draw it out, so we got 2x plus y is 12. So what you can do is you can actually you can just solve it. So 2x plus y is 12, which means when y is 0, x is, what is x? X is 6. So you got this weight number here. And when x is 0, y is 12. So that's how you kind of draw the line. Just get any 2 points and you will be able to draw the line. So this is the line here, right? And the next one is that absolute of y is less than 12. So absolute of y is less than 12. You can actually break it down as y is less than 12, but greater than negative 12. So that would be all the way from negative 12 to 12. So 12 goes here. So that means all of this area falls here. So now the question is asking is how many ordered pairs of this solution where x and y are both integers. So basically, how many points on this line all the way from here till here are integers? So by the way, this is 6. So you've got 7 values here. So starting from 0 all the way till 6. So you got 7 values, 0, 1, 2, 3, 4, 5, 6. So that's 6. And this is 12. And you got 6 values here from 6 to 12, right? You got 6 is already counted, 7, 8, 9, 10, 11, 12. So you got 6 values here. So you got a total of 7 plus 6 values, which will be integers. So that would be 12. Sorry, that would be 13, which is the answer. Right, so that should solve it. So the answer is 13. You will have these values because if x is an integer, y will turn out to be an integer. Why is that? Because if x is over here an integer, and then they'll just go there and subtract, and y will turn out to be an integer. So you can start with x. Don't start with y here because then you'll have to figure out the even numbers. Just do with x because you just want to say if x is an integer, y will turn out to be an integer. But that's not the other way around. If y is an integer, that doesn't mean x will be an integer because it depends whether y is even or y is odd. So you have to figure out using x only. So that gives us the answer, which is 13, which is answer option D. So I hope this video is being useful to you guys. I hope you're understanding what I'm saying. If you have any questions, you can put it in the comment section. Now we got 2 more questions left. Let's move on to the next one. Okay, let's solve this question here. So this says, how many times will the digit 7 be written when listing integers from 1 to 1000? So there are 2 ways of answering this problem. First is you literally count the number of times 7 will be written. You will overcount. You'll have to subtract those overcounts. So that will take a lot of time. The other way of solving this question is actually using probability because number of digits are actually equally likely to be used. So for instance, if you consider 1 to be as 001, right? So if you consider it to be like this, so the next number is 002, and you go all the way till 999. So you have basically 1000 numbers, and you are using 3 digits for all these 1000 numbers. So you're basically using a total of 3000 digits. Right? So you're basically using a total of 3000 digits. And the number 7 is equally likely to arrive out of all the digits. So from 1, 2, 3, 4, 5, 6, 7, 8, 9. So number 7 is equally likely to be part of these 3000 digits. So number 7 has 1/10 of a probability to arrive to be used. So that means a total of 300 numbers will actually use number 7. So that's the answer. So you can actually use probability to answer this question rather than actually counting the number of sevens. So the way I did this is I considered 1 to be 001. So that way I have all the numbers to be considered as 3-digit numbers. And then we counted there were a total of 3,000 times digits were used. So 7 should be used equally likely. So there are 10 digits. So it should be used 1/10 of the time. So the answer is 300. So that solves it, right? Now let's move on to the last question. So this question says that there are a total of 100 people attending a conference. Then you've got writers, so people who are writers and not writers. People who are editors and not editors. So I'm using the table approach, right? So I have a video on that, you can watch it. It says 45 of them are writers, so 45 are here. And there are a total of 100 people, which means 55 are not writers. And 38 are editors, which means 62 are not editors. So the question says that X are both writers and editors, right? So of the people at conference, X are both writers and editors, and 2X are neither. So 2X are neither. So they're neither writers and nor editors. And one more caveat to the question is it says 45 of them are writers, but there are more than 38 editors. So there are more than 38 editors. So that means the maximum it can be, the minimum it can be is 39. So let's just keep it this way. So at most, this can be greater than 62. So let's just, let's not deal with inequalities right now. Let's just try to solve the question this way, and then we can talk about least and not least. So the question is asking us, what is the largest number of people who can be both writers and editors? So what is the largest number of people here? So, well, the most this can be, the least this can be is 39, right? So that's the least it can be. So that's there. Now the question is, so we have to find the value of X. So I can use this particular box to find the value of X, because this one here is 55 minus 2X, right? Because I can solve it using this particular instance. And this one here is basically 38 minus X. So they are both equal. So if I solve this, 2X goes this side, 38 goes this side, X is actually going to be equal to 55 minus 38, right? So if I solve this, this one is going to be 17. Now there's a trick to the question. 17 is not the answer, because this has to be less than 17, because this one here is at least 30. It has to be greater than 38. So this one has to be, the least it can be is 39. So that means it's one more number, which means this is one less number. So the maximum it can be is 16. It cannot be more than 16. So this one at maximum it can be 16. It cannot be more than that, because if it becomes more than that, then I will actually violate this condition that there are more than 38 editors. So that solves the question, guys. X, the answer over here is actually 16, not 17. 17 is actually the trick answer, because the way the question is written, that there are more than 38 editors. So I hope you understood this question here, guys. This is the answer, which is 16. So thank you very much for watching this video, I will be adding more content. Please subscribe for more content, and I would be adding the new GMAT course as well, which is the GMAT focused edition, for the current GMAT as well, I'm adding more content. Please subscribe for more content. Thank you very much. I'll see you in the next video.